Need to show something that isn't won't be as clear. Okay, so each one of these is going to have a label, and you may need to talk about them later. Okay, so let me start with one of these guys, which I'm sure you've all seen before. You may even use them. It's a heat pad. And remember, everything I'm doing here today, you should be able to kind of tie back somehow to one of the chapters that we studied in our thermal physics unit. Okay? So this is solid now. Pretty solid. It's a bit of a gel. And then this is a liquid. You can see that this is a liquid now, right? See that? And you may have seen these before. I'm going to do two for one. So this is a heat pad. And the ones that you buy in the store, the cheap ones usually are those ones that maybe you shake up. They use a certain reaction too. This here, I don't know if you can see very well, but this here is LCD. It looks black until what happens? Mm-hmm. So I'm going to take this, there's a little disc in here, and I'm going to pop it. Watch, you see that? Okay, I'm going to mush it around a little bit. I'm going to take my LCD. See that? Okay, so a couple of phenomena going on here. Two phenomena going on here. Cool LCD sheet. Okay. All right. It's demo number 1 and 2. Heat pad and LCD. The one we have right here, the bobbing birds. Okay, the bobbing birds, I've got two. I just had two. They're different sizes. When I got them started, I dunked their head in water. And then once I dunked their head in water, I should have probably shown you so that I could have, we could have seen it from the beginning, but it was dry. I dunked their heads in water, and then I just stopped. Now, notice everything carefully. You're being scientists now, so you need to be very careful about what you're observing. Notice the liquid, the blue liquid and the red liquid inside of the birds. Notice the relative frequency at which they dunk. I might be able to speed that up. I would blow on them, but blowing these days is a crime. So I'm going to use this little fan. Does that seem to speed up the frequency? Notice how fast that they're normally dunking their beaks. And notice what happens. The guy's taking a long time. There, almost there. I'm looking at Bluebird now. He's almost there. There he goes. That took quite a while. Notice what happened to the liquid when he dunked his head. Let's see if I can speed that up a little bit. See how much, did you notice? It's much faster. Why? Okay, that's our dunking birds. They will continue to dunk even without the water for a while. Get them out of the way. Bobbing birds. Here I have a radiation vane. Vane, V-A-N-E. Sealed inside there on a very, very low friction spindle. And it's spinning around. Observe the vane. There are two different colors. Why? Which way is it rotating? Why? Does it matter if I move the candle over here? If I'm looking down on this, right now it's rotating clockwise. What if I move the candle over here? Does that make a difference? Did that make a difference to the way that the vane was rotating when I moved the candle? Is that important? Okay. Next is our Stirling engine. Stirling engine is going to go back and talk about another property from our previous chapter. You'll see in a moment. I've got a heat source here, an alcohol lamp, and it is heating up this contained tube of air. The air has a piston in it. Okay? So it's heating that up. It takes a moment, and it needs a little start. Give that a minute. What phenomena are we also seeing from our previous chapter? What did we do before? What's our topic before thermal? Electricity. Ananya, this should make sense to you, right? Notice the blue light, right? You see that? Okay. So this is a simple Stirling engine or a heat engine. Okay, that's the heat engine, still hot, don't want to touch it. Next, I need a volunteer for this one. Shen, you're close. I have here two very heavy metal balls. Shen, would you hold this piece of paper for me over here? Just hold it like that. There you go. So I'm going to take these two balls, and they're nice and clean. There's no rust or anything on them. They're quite heavy. They're solid steel. And I'm going to take these two balls and hold it to each other. There you go. Thank you. Shin, could you smell that? What does it smell like?
Smell like metal.
Like metal?
Yeah.
Let me try a little. You smell anything else?
Is it fire?
Pass that around. Oh, maybe it's not a great idea to pass things around and then have everybody smell them during a pandemic. So don't take your mask off, but see if you can smell what's going on there. Actually, and please don't take your mask off, but you can also look closely at the edge of the holes. What has happened there, okay? That was the collision balls. Collision balls. Okay, we're going to make fire again. Would you get the lights, please, Eric? You've seen this one, but I'd like to show it again. I put a little piece of cotton in this syringe, okay? And I'm going, it's nice and it's screwed up and it's nice and airtight. And now I'm going to, I need to be careful I don't break anything. I'm going to depress the plunger as quickly as I can, and we'll see what happens there. Am I still recording here? Can you tell? Is it counting down? Okay, thanks.
It says recording.
It says recording and it's counting?
Yep, 47.
Excellent. Okay, let's see if I can do this on one try. Watch closely, right around here. Okay, here we go. 1, 2, 3.
Ooh, first try.
Pretty quick though, right? Okay, which chapter was this? Which concept was this in our thermal physics unit? All right. Eric, would you get the lights again for me? Thank you. That was the fire syringe. This one you've seen before, but a lot of these things I showed you online with my webcam, and I'm not sure if you got to see it very well. The next one is bimetallic strips. This might take a second. So here I've got, and this is important, okay? This is brass, and this is iron. And they have been riveted together. These little screws without heads are called rivets. It's important, the two metals. Let's see what happens. Not getting much movement there. I've shown you my other bimetallic strips, but they were welded together, and it wasn't as clear that there were two different metals. I'm actually getting a lot of soot. You see that? The soot does not help when it comes to transferring the heat. It acts as quite an effective barrier, actually. I didn't get what I expected, but it's an observation. I'm not going to sit here too much longer. And that was brass and iron. Let's try iron and copper. Got copper, we got iron. Two different metals. See if we get a better result here. Here's a bimetallic strip, but notice there's no rivets. That was not a very impressive result. think that's much more clear. So these ones that were riveted together didn't go exactly as well as I thought they would. That was bimetallic strips. Let me now redo an experiment that I did online the other day. Here I got a metal block. This is a plastic block. I'm going to need some ice for this, so I'm just going to run to the back real quick. I put these rings to help stop the water from going everywhere. I was quite impressed at how quickly this one works. So I got 2 ice cubes. They're the same size, roughly the same size. And I put them on the metal block and on the plastic block. We notice what happens right away. Very dramatic result. You may need to come closer to see this one, I'm not sure. Why don't you come a little bit closer? Maybe in turns. Why don't you guys come walk by? You guys first. You don't have to walk if you don't want to. I know your leg is... You see that? Look how quick that is. You guys behind, why don't you come up and have a look? You guys can go sit back down. You see that? Look at this. There's not even a drop of water on this one. Okay. Next group, why don't you come and have a look. I'm not sure how well you can see it from where you are. I think it's quite impressive what's going on here. You can even see this one on the metal block here is just moving around. Slipping and sliding. So I showed you this one already, but it was online, so I wanted to do it again in person. Not a drop. And lots of drops. Okay? That was the melting blocks. Eric, would you hand me another couple of paper towels, please? Thank you. Next, I'd like to show you the chimney. So I'm going to take this candle here, and I'm going to put it in this box. I'm going to slide this glass door closed. Maybe I'll put it over here. Okay, and now I have these little incense sticks, but maybe I'm going to try something that will make a little more smoke. I don't want to set off the alarm. Got some smoke. I'm going to close the lid here. Let's see if we can see what starts to happen. I can't see it. Are you seeing it?
Yeah, I can see.
Okay.
Smoke's going down.
You should think of the word for this. We have a word for this, right? If I open the glass, it doesn't work as well, does it? You see that? When I close the glass,
Smoke. Smoky.
see it begins to happen. There's something happening there. Okay? That was the chimney. Got a couple more. I did this one last week as well, but it was online and I was pretty sure you couldn't see it. I've got here 4 metal strips. I've got brass, steel, brass, aluminum, copper. Steel, brass, aluminum, copper. And that's important. Remember that, write it down or record it. I got some boiling water, hang on. It's not boiling anymore, but it's still hot. And maybe I'm going to stand here and I'm going to dip this in, all 4 of them, into the same water. Let's see if you can tell the difference now. We weren't able to see this online very well last time, so hopefully this will be a little better. This is an LCD strip attached to these metal strips, just like I showed you in the first demo. Why? Don't answer, think about that. Why is there an LCD strip attached to the front of this metal? Can you see anything? What do you see? What do you notice there? Can you see the colors? Yeah, the colors aren't that easy to see, so I'm going to bring it closer to you. I don't think you were able to see this online last week. See the colors? See that, Isabel? Can you see the colors? The colors are supposed to light up a number. You see? You see the colors up here? You guys can see those? Can you see those?
Yep. 39.
Okay.